the note set here, you're going to see probably 2 or 3 other types of problems in the online prep quizzes out there. But let's jump over to the counting side of things right now. Counting had 2 different types of problems, counting and probability together. What was our basic go-to technique in counting and probability exercises? Blanks. So in this particular case, we have to get an identification code. An identification code has to have, so letter, 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 and then it has to have number, 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 number. So how many letters do we have to select from? And how many numbers or digits do we have to select from? How many figures do you have? Assuming you haven't had an industrial accident, or you're not a genetic anomaly. 10. Not 9, 10. 0 is a digit. 1 through 9 is 9, plus 1 more is 10. Special requirements.
Letters cannot be repeated. Numbers
Cannot repeat. Numbers. Cannot repeat. First 3 must be odd. Special conditions. It's an identification code. Does order matter? So, those dashes or lines that you drew become fraction bars, which means that the denominators all will be 1, because there's only one correct first letter, only one correct second letter, third letter, fourth letter, first digit, second digit, third digit, fourth digit, fifth digit. When order doesn't matter, then the denominators are going to change and decrease as you go down the line of the problem. So those are one of the inbred questions that you have to remember to ask yourself. So numerator's now going to talk about what's acceptable. How many acceptable first letters? How many possible first letters? 26. And now because you can't repeat, 25, 24, 23. How many digits to select from at the outset? 10, but the digits on the beginning all have to be odd. So how many are actually okay to use? 5 of them. So 5. And then since you can't repeat, 4. And then 3. But now what about the last 2? They could be even or they could be odd. Didn't say you can't use the odd ever again. It just said the first 3 had to be. So you have 5 even, because 0 is an even number. And don't you still have 2 odd numbers you haven't used? So total number of items for the 4th digit? 7. And then 6. They'll try to throw wrinkles at you, like the first digit has to be an A, B, C, or a D, or the first 3 letters have to be the same, or something like that, but you still can think your way through the problem. Now that turns out to be rather a large multiplication problem, but We just kind of have to suck it up and deal with it. So we got 26, 25, 24, 23, 5, 4, 3, 7, and 6. 1, 2, 3, 4. Okay, so I think I typed it in wrong, right? Okay. So we have 904,176,000 possible identification codes that we can get. Commas are optional. If you put commas in, they got to be in the right place, however. I would expect that this would be something that you would share with me. Because there's your support for the problem. And if that's not right, that explains why your answer is not right. But it also dictates what you can get for partial credit. You may have made a mistake on you may have done the number side, the letter side of the problem right, but messed up on the number side. Well, you're going to get some partial credit for what you did right. So the program takes everything away, but you earn back things by showing me in your problem what goes on. So important questions. Does order make a difference? That's a real important question. If order doesn't make a difference, it's going to change the dynamics of the problem a little bit.